Another common display used in statistics is a histogram. The histogram is used when we have large sets of data, and that data is continuous. When we display on a histogram, because it's continuous, typically the bars are next to each other and we have no spaces. So here's an example. There are 20 students here. We're going to break them into 4 classes, and it's based on their GPA. So when we break them up, a natural class would be GPA of 0 to 1. Now notice I put parentheses on the left and brackets on the right. The parentheses mean do not include, and brackets mean to include. So what that is saying is you include a 1.0 in this class. The next class would go from a 1 to a 2. The 1.0 is in class 1. The 1.1 would land in class 2. 2 to a 3, and a 3 to a 4. So when we start tallying, all we do is we look at 0.8. 8/10 lands in the first class. 1.4 in the second, 2.9, 2.7, 3.2. 3.2 lands in the last class. A 4.0, notice it's included. It lands in the last class. 2.5, 3.75, 3.1, 3.4. So we just tally. So go ahead and tally those up, and we'll check here in just a moment. So when I check my tallies in the first class, I have 1. So we're going to construct it like a bar graph, but it's not a bar graph. Bar graph was, if you recall, was used for qualitative data. Histogram is used for quantitative data. They are going to look similar, but the categories on the bottom of a histogram can be ordered. When a bar graph, they were words and had no order about them. So we're going to go from a 0 to a 1, to a 2, to a 3, to a 4. And the axis going up represents how many people there were, and so forth. So in the first one, I would have 1. And notice it's continuous. So right after 1 comes the next value, and that person would have fit in the second class. And then we'll go up 6. So we'll count 1, 2, 3, 4, 5, 6. So again, it's similar to a bar graph, but yet it's quite a bit different. And the last one is 10. The bars, again, are equal length. So when we look at this, a histogram is very good for looking at the distribution. So when you go and look at your models, this one looks like it would be skewed. And my tail's here, and then it comes up. So it looks like it's skewed left. Histograms are used often, and they're very good for determining the model. Don't confuse histograms with bar graphs. Time plots. It's for plotting time, and we use these to make predictions. We want to predict from the past what might be happening in the future. So we're going to use a coordinate system. So from algebra, that's an x-axis and a y-axis. These are positive x's, negative, positive y's, and negative, and this is the origin right there in the center. And we're going to plot values. So the values are going to come in this ordered pair x, y. Let's go ahead and take an example, look at an example. So here's my grid. In the year 2000, I had 800. So what we need to do is scale our axes. So for this purpose, I'll scale. And when you're reading a graph, you always want to check what the scale is on both the x and the y axes. So we're scaling here by 50, and we started at 750. So we have a broken graph. Then we're going to start at the year 2000, 2001, 2, 3, and 4. Plotting this would be my x. It's my independent, so it is my x-axis. So I'm going to 2000 up to 800, and I just place a dot there locating that point. 2001, I made it 825. 2002 at 900. 2003 is 910. And 2004 is 940. So if you see there, it looks fairly linear, like it would form a line. So to look at the trend here, it looks like it is gradually increasing. And back in algebra, we would call this a linear equation. So the population follows somewhat this trend. Okay, and I just eyeballed what we call the line of best fit. So what we do with this line is we predict. We want to look into the future and say, okay, if I can follow this trend, what might be my population in 2005? And according to my model, I would go to 2005. It would be someplace in this range here, which looks like between 1,000 and 1,050. Models are very inaccurate, but they're very good for giving us some sort of an idea of what might be happening. So histograms are used for continuous data. Time plots are used for trends and predictions. Little look at scatter plots. We have some definitions here, and again, this goes back to algebra. We have the dependent variable, which is the response or the output. It's what I'm going to predict, and the symbol for it is the y. It's the y coordinate, or the second coordinate in the ordered pair, and the axis is the vertical axis. So when I'm plotting it, this is the y-axis. The independent variable is the explanatory variable, or the input. Its symbol is x, and its axis is the horizontal. So this would be the x-axis. Now when we look at a scatter plot, we like to look at the display of the x and y ordered pairs to see what the cause and effect relationship might be. So it shows the effect or the relationship between the response and the explanatory. So it gives me a visual picture of what's going on. So in the last situation with the population, we could see its trend is to increase linearly or at a constant rate. So when we have these pictures, we like to look at how are they associated? How is the response and the explanatory associated? And we basically have three. We have a positive, which means that it is increasing. And it's when I have large x's paired with large y's. So a picture of that would look like this. That's in a positive direction. A negative then would decrease. So taking a look at a negative association, that means the values go down. So we have large, in this case, large y's with small x's. These are small, and these would be large. And then out here I have large x's, but small y's. So you just look at the trend of the picture. You can see that this is headed up positive, this is headed down negative. And then the last situation, there might be no association at all. And so what that would look like is these are scattered about. Now you might want to say, well, there might be some linear trend in there, and that is true. And we use technology to determine that. But for right now, we just want to make sure that, okay, they're just scattered about. So something with no association might be how tall you are and your IQ score. There's no association there. A negative association of positive, if you look at these, it might be the more you eat, the more weight you're going to gain. Something of that effect. So there's some examples of those in your textbook for some practice problems.